charge of communication and press office area of ANFIA, the Italian Association of the Automotive Industry. ANFIA is one of the 11 partners of SURE5.0 European project, a project within the framework of Horizon Europe program. This project aims to support the SMEs, the European SMEs of 3 different industrial ecosystems, automotive and transportation, aerospace and defense, and electronics, in their digitalization processes, while becoming more human-centric, resilient, and sustainable. The webinar of today is dedicated to virtual reality, augmented reality, and mobile robots as technologies for production and logistics sectors. We will delve into the transformative potential of these emerging technologies. And we will start with a speech given by Alexander Kreppein, a research fellow and project manager of the Fraunhofer Institute for Production Technology. He will delve into the applications of virtual and augmented reality in modern production processes, starting from a question: how can smart devices help in an industrial context? He will make us consider that there is a great variety of smart devices that can be used, each one with a different level of technological maturity. And he will also focus on the differences and the different applications among augmented reality, mixed reality, virtual reality, that's to say, conducting us through a transition between real world and virtual world. He will explain how these new technologies can be useful in terms of quality and cost reduction, but there are many factors we have to take into account for implementing them. First of all, people's acceptance. The second speech will be given by Kashif Mahmood from the Department of Mechanical and Industrial Engineering of TALTECH, Tallinn University of Technology. And he will concentrate on the role of mobile robots in factory floor logistics, considering autonomous mobile robots and automated guided vehicles as how can we say material handling equipment, exactly like forklifts or cranes. And he will illustrate their technological impact on production logistics, opening the door to the concept of smart factory. He will also describe a conceptual model to implement mobile robots in intralogistics, in production intralogistics, and a related case study that will lead us to some interesting conclusions. In the end, we will have the final speech given by Alessio Gugliotta, Senior Program Manager of EIT Manufacturing. He will explore the innovative XR2Learn approach for using extended reality in education and learning environments. XR2Learn is a European project started in January 2023 and dating 42 months. It gathers more than 2,000 community members from more than 20 different countries. And its objective is to establish a platform-based and cross-border innovation community for extended reality application in education and training. Since Europe needs to improve its competitiveness in extended reality market. In this case, when we will talk about education, we will refer both to the education of young engineers, of students, but also to the reskilling and the upskilling of today's workers. Now, some practical information before starting. We will have a Q&A session at the end of the webinar. So please, if you have some questions, put them into the chat and we will read them and answer to them at the end. Please keep muted your microphones and switch off your camera in order to save band. And I will also remind you that the recording of this webinar will be available, I think, between this afternoon and tomorrow on SURE5.0 website. So now we can start the webinar. So please, Alexander, the floor is yours.
All right. Yeah, thank you very much also for the announcements. My name is Alexander Kreppein. I'm a research fellow at the Fraunhofer Institute for Production Technologies. We are working with technologies in the context of digitalization, and we're always asking how can these technologies help and improve production processes. And one of this field is virtual and augmented reality in production. And today, I would like to give a small overview of this technology and the potential that it has for production. I would like to start with the first picture to give you an idea of what changed and how fast the changes can be. Here we have a picture from 2004. George W. Bush gives a speech in Orlando before his re-election. And I would like to notice the audience in the background. And then now we have a comparison to Donald Trump, 2018. He gives a speech and we can see the background changes. And one object that noticeably changed was the phone that everyone is now holding in their hands. I think this is quite obvious to point this out. And we all know that the phones are getting better, the devices are getting better. So here, for example, smartphone nowadays has lots of functionality in it that was previously a separate device. And the same, of course, for other technologies that we are going to look in. And these technologies, of course, developing in a very quick way. And the question that we are always asking at the Institute, how can this help in production? And to answer this question, I would like to look at this particular chart here. This is now an example from Germany. And we looked at the work distribution in production and assembly. And we divided, or the data shows the amounts from manual work, partially automated, and automated processes. And if we think about how can we use the technologies that we've seen before and that I'm going to present later, how can we use them and how big is the potential? We could, of course, look at the automated area and there we're going to see, and if we think about it, it doesn't really make sense in this area to introduce some kind of smart device. In the partially automated area, it starts to get more, or it starts to become more interesting, because here we can use the technologies to improve working together with an automation and with the machines. And manual work, the biggest area, this is also the area where smart devices, smart technologies can support processes in a production. So here is the biggest potential, and you can see it's the biggest field even nowadays. So there's still a huge potential for those technologies. The question is now, of course, we've seen smartphones before, and we know there are other devices that I'm going to introduce. But the big question is, of course, how can smart devices help in an industrial context? And to start this idea and start this discussion, I would like to introduce what kind of devices are on the markets nowadays and what kind of, or how can they help? And we're going to see some of the devices. The first one The one that I've shown before with the images of the US presidents, tablets and smartphones, of course. Big advantage, they are commodity, you can buy them, they're quite advanced. And of course, they are very flexible in their use. And they can, of course, be used in a production line. Then we have lots of single sensors that can be used to connect to machines, for example, QR codes that help to connect to one of the devices. We have smart gloves are on the market that help with sensing abilities. There are similar to smart gloves, gesture control technologies that can help identify a certain gesture. The smart glasses are one of the fields that we're going to talk more in depth later in this presentation that can help realize different use cases. Eye tracking technologies, of course, they can also help in certain use cases. Then, of course, industrial image processing technologies. And then we have more specialized equipment, for example, equipment that can identify muscle movements, and of course, smartwatches that are on the market nowadays as well. And the technology, where you can see that there's a wide variety of technologies. Of course, in the end, they always depend on the use case. But to give a better understanding also from or which perspectives we are talking, usually we split them in, or we divide the devices and rank them based on the level of integration of virtual reality in the real world. So starting from the real world, of course, this is the baseline where we start. First technology that's often used is augmented reality. So here, virtual realities are overlaid with the real world. So this can be, for example, here it's a smartphone, but of course, this can be done with a smart glass, where we can see additional information besides seeing the real world. There's mixed reality. This is now more coming to virtual worlds where you have more virtual interaction, and the reality, the real world is less in the focus. And then you have virtual reality. So this is now a fully artificial world where you can deploy different use cases. This is, or we should give a short introduction of the different areas that there are on the market and the different devices that can be deployed in one of these areas. It's important to know there is a smooth transition, so there's no clear line that can be drawn. So, but depending on the use case, depending on the devices that are used, this can be, or it's usually not very distinct where to draw the exact line. So this is just to give a small overview what is available. I would like to now give you some ideas and focus a little bit more on augmented reality, virtual reality, and mixed reality. And here we have another example, virtual reality, now not in a production context, but I think it's easily understandable how this can also help in a production context. And mixed reality is now more focused on the virtual aspect. And then lastly, virtual reality. So those are the three different pillars that we would like to focus a little bit more in depth now. So augmented reality, it's used when the real objects are supplemented with additional information. And some examples are logistics that receive visual information on a location of a product, or mixed reality. This is, for example, an example is a digital twin of a robot that can be controlled in the real world. And virtual reality, an example is production planning of a new factory or training materials. For all of these examples are different technologies on the market. Here are just some examples that are on the market or were on the market. It's important to know that these technologies change quite quickly. As smartphones are changing, also the other technologies are changing. So it's always important to look at the current situation, what is on the market at the moment. And I would like to give you one example where especially augmented reality can help in a lot of production contexts. And this is the context of remote support and remote maintenance. This is a use case that's coming from a company that was founded out of our institute. Oculavis is the name. And they noticed that not a long time ago, usually customers, if they require assistance, often they call us the manufacturer of a machine, for example, and then a service employee drives to the customer and does maintenance or helps with a certain technology. Or if they don't want to drive, they just pick up the phone and have some kind of like phone line. But of course, they can't really help in more detail. And they founded a company for remote support and remote maintenance with augmented reality glasses. So the employee itself can use the glasses, can look at the machine and gets additional information. For example, if it's a special kind of machine in which requires some kind of maintenance, you can see on an augmented screen the information that is needed to do the maintenance in the direct steps, in the correct steps that are necessary. And this can also be connected with the person which is from the support team. But instead of driving now to the customer, they can now sit in a virtual room and give guidance, and they can also see what the person is seeing. So this is an example, quite successful example of a company that was founded out of our institute and that's now helping customers. But this is not an advertisement, so don't get me wrong for this company. There are other companies out there as well. It's important to look at your use case that you have and then select the right technology. And to do this, I would like to just point out some aspects that you need to consider when you want to implement such a use case. And important here is these technologies, they have a focus on people, and people require or have some limitations. And for example, you need to look in ergonomics. Those devices, especially the early generations, are quite heavy, so it's not very pleasant to work with them the full day. Very important is the use case. Not every technology makes sense for every use case. And our suggestion is always to look at the use case and then based on the use case, select the right technology. The hardware itself, there are different hardware manufacturers for different technologies. So it's important to select the right hardware. Acceptance, of course, this is a matter working with people. People need to use the technology and they need to accept it. Otherwise, companies are going to have quite a big problem selling the products to their employees that they would like to use. Yeah, legal aspects in European countries, especially also in Germany, need to be considered. Safety and security, of course, as well, especially technologies, virtual technologies. It needs to be made, or it needs to be safe. And of course, security is also important when it comes to relevant data, and then change management. So if you, or I hope that maybe you have maybe a use case in your minds where you say, well, this could be a use case for this kind of technology. Maybe the first question that comes up is, which smart devices are the right devices now for my application? As I said, it depends on the use case, so I cannot give you now one recommendation or a general recommendation because it always depends on the use case. But there are tools that can make your decision easier, or of course you can talk to experts that can help you make the right decisions. Maybe just one tool as an example of how it can help you is a guide for smart glasses. It's on the smartglasses.guide. I'm sorry that the screenshot is in German, but browsers can now translate it in English. They can help you select the right devices and point out pros and cons of the devices to help realize your use case. Yeah, and I hope that you can realize some of the use case and can use the inputs for the use cases. This is it from my side. So thanks a lot for your attention, and I'm looking forward to the other presentations and the discussions at the end. Thank you.
Thank you, Alexander. It was a very interesting overview of these emerging technologies, and I hope there will be some questions from the audience to deepen the matter. Now let's switch to the second speech. It will be given by Kashif Mahmood from TALTECH, and we will delve into indoor logistics by mobile robots. So please, Kashif, the floor is yours.
Okay, thank you, Miriam, for your introduction. I would like to share my screen. I hope you can hear me well enough.
Yeah, we can hear you. Okay, we can see your screen. Let's start.
Yeah. Okay, so hello everyone again, and my name is Kashif Mahmood, and I'm working as a researcher in Department of Mechanical and Industrial Engineering in the Tallinn University of Technology. And today I'm going to talk about the role of mobile robots in production intralogistics, like how mobile robots can be deployed for the transportation of, let's say, different products or goods on the factory floor. I will go through the topics, or let's say the content of this speech or the presentation. First, I will go through the introduction to mobile robot as a material handling equipment, because they are like the under this umbrella where we have different equipment used for the transportation. Second one is technological impact in production logistics. So how the technology, let's say, have the impact, and how the things now can be seen there, and the implementation of different tools and the hardware for the production logistics. Then I will introduce one conceptual model that we tested also to implement mobile robot. That is followed by case study and results, and in the end I will end my speech with some outlook. So here is something that what is material handling and where the mobile robots are located, or let's say could be deployed. So as I said, that mobile robots used as a material handling equipment, and material handling is one of the important pillar of production system, especially if you processing or assembling of discrete parts and products. So the functions of, let's say, material handling is loading and unloading work units at different workstation, positioning like some jigs and fixture. But one of the main tasks also to transporting work units between station, let's say multi-station systems, or let's say different workstation on the production line, or different areas, production area, warehouse, and so on. So this is the main function that we can see the mobile robot can be deployed. And on the other hand, I list down some equipment that are already working in different or deployed in different industry or the production floor. These are conveyors, forklift, let's say the pallet jack, which for manual transportations, and the buffer racks for storage. But the AGV and the mobile robot, like the automated guided vehicle and mobile robots, are also now, let's say, what is it, taking hype, or quite get in for this transportation of goods on the production floor. Here is the motivation, actually, that's what is the aspects or kind of motivation to implement mobile robot, or we now call autonomous mobile robots. So on the left side, there is some kind of motivation that how the, let's say, smart manufacturing or digitalization have the impact on the transportation or let's say production intralogistics. So the idea is to automate the repetitive process of transportation of goods on a factory floor, and this can be let's say addressed through AMR, like they are the one that can be used to transportation of goods from one place to another, and they can help to create an economic workspace in a sense that the repetitive task can be done by the mobile robot, and it also leads to the well housekeeping that you cannot like deploy the mobile robot if your floors are not clean, and if there are many obstacles, then there is no point to, let's say, deploy mobile robots. So the planning and other also helps well-being or the good housekeeping of the of your production floor. And the other motivation, let's say, to use these modern technological assets for the transportation and integrate to this IoT or AI. So mobile robots are not, I would say that deploy lonely, or because there is always some integration because of the autonomous communication and other. So there are always some IoT sensor and machine vision technology that must be integrated with the mobile robot. And also the in the end, the production company is always looking at what is really the outcome. So here the idea is to improve the performance of production intralogistic by means of some KPIs, which are like on-time delivery from workstation to workstation, or from one production area to another area, and reduce labor cost and the fatigues. So that's the idea, that some motivation and how the AMR can help or tends to help to address those motivation, which is also let's say popped up by this new technological impact. So I put this slide in a to little bit to talk about the, how we see the AGV and what is AMR. So AGVs are been there in the production, I would say, for a while, and which is automatic guided vehicle, but they always follow the fixed path and predefined path. But for the mobile robot, the autonomy is there. Like there are sensors and there are vision systems, so that they can like more flexible and can be pass through different obstacle without like do some more programming and other. So they can be like autonomously move in the production area. If there are some human interruptions, or if there are some different obstacles, they can take the other path and sense this kind of obstacle on the production floor. Then I have a couple of more, let's say, application. That one is the transportation of boxes that I'm gonna explain through my case study also, and the other one is the mobile robot also using in the combination of cobots, and we have some kind of lab developments also, where we're trying to test that how the mobile robot can, let's say, move or together with the cobot move from workstation to another workstation, so that their utilization could be increased. To move forward, I have this kind of, since I'm a researcher, I'm just mostly think about from the let's say the conceptual models and other. So we have some kind of case study to solve, and we created that how we can implement the mobile robot in that environment. And for that purpose, we develop some generic model, which will say the conceptual model that start with the idea generation. Let's say the idea was to automate the transportation on the production floor. Then there was a planning, and planning we just took the simulation let's say tool for the validation. So there is idea, then there is a use case, and then how to validate that mobile robots are feasible. to implement in the production floor. For the validation, we tried the 3D simulation scenario. We create the virtual environment, let's say the digital model or digital mockup, and capture this knowledge, capture some KPIs, see the feasibility. And the third phase was the verification, where we did some experimental, let's say, the study, and see that what we get the knowledge from a virtual environment, and we test it into the real environment, and also have some feedback from there and change our virtual environment. So it's a kind of, again, you can say that the inception of the digital twin of that area, but of course not the full digital twin, but let's say the digital mock-up, because it was not really online, it was offline evaluation, assessment, and then the verification for the experimental study of the mobile robot in the real production environment. Okay, yeah, so I was telling that, describing the case study, that there was a food manufacturing company, they're producing ready-made food, and there was a main issue is that transportation of boxes from one place to another, and they are really intended to deploy or test this mobile robot application there. So the main objectives for this case study is the transportation of the empty boxes from one place to another. I mean, washing area to, let's say, they have some kind of intermediate storage, and from production area to this finished goods area, and some raw materials to also the production area. And in the right side, you can see that there is some kind of testing. We have done it for the transportation of boxes through the one mobile robot. As I said, that we also tested the virtual environment for the validation or check the feasibility. So we use one of the 3D simulation software. It's called Visual Components, and we ramp up, let's say, one-to-one scale environment of this production, especially not the whole production, but especially the routings of the mobile robot, where they let's say moving. So movement of the mobile robots was the main target, and we planned the distances from, let's say, one area to washing area, the production area, and from warehouse to production area, and did this simulation into the 3D world. And the idea was to test some kind of KPIs, which is first one to in terms of inventory. So it was about how we can cut down this work in process inventory on the production floor, and also how we can also deliver the boxes at the right time at the right place, because they don't have any clue how many boxes needed in which area of the production floor if they're doing some manual tasks. So, and also in the end, how the cost of the, let's say, of the investment, how many robots they needed, and operating cost also we analyze it, and also it helps in the end to cut down the workers' fatigue level. So here is the the mapping of the production area where we deployed the mobile robots, and here is some kind of video that I have it. So we ramp up. We have, like, let's say, the floor plan in, let's say, developing this AutoCAD environment, and we just have the same floor plan into the 3D environment, and we build up on top of it this kind of virtual environment where you see the mobile robot is moving to taking some of the raw material, let's say boxes of carrots, because the idea is to prepare some carrot salad there. So anyway, and then there is some other, which one is the washing area, where they need, where the mobile robot, the task is to take these empty boxes and transport it to this production area. So This is one of the also main route or the movement of the mobile robot that we tested and analyze it. And yeah, I think the video is a bit long. I tried to move it a little bit faster. So anyway, the idea is to transport here the boxes from the washing area. Let's say we pretend here the washing into this packing area, and then there is some process of packing which we also, let's say, simulated, but in the end the idea is to also mobile robot moving from one of this production area to take the boxes and put it to the finished goods area. So there are different areas that mobile robot plan to move it, and the idea is to check the feasibility, this implication, and what are, let's say, the KPIs improvement in terms of transportation task, and like the timing of the transportation and so on, and how many mobile robots we needed to fulfill their daily demand, let's say. Then we deployed this thing or tested as experiment into their facility, which is the real facility. So we tried even with a couple of mobile robots that we have it in our institute. One is developed even by our department. And then we analyze it that what is the current scenario, what is the virtual scenario, giving some kind of outcomes. And when we test it in the real scenario, then what could be improved and what was the estimated improvement for the KPIs. So there are some improvement, although not that significant, but definitely there was just a small test. So we have some improvement we cut down the irregularities, let's say, in the existing system of the transportation of goods from one place to another. And also the things planned well. The delivery of the boxes from one place to another was on time, at the right place. Some throughput was increases, let's say, from 321 to 336, and also it helps to reduce the, let's say, the workers fatigue level, because it's quite repetitive task for the mobile robot. It's more like the plan, and this fatigue level was reduced. So in the end, I have the outlook from the case study that the mobile robot can be used for the automation of the intra-logistic. However, there are limitations in terms of size and weight. So this we need to think about it and see what our goals and what are the products that we would like to transport. Also, the KPIs analysis revealed that it is feasible to do it, and do it like the implementation of AMR, and they can help to enhance the proactive decision making. And also the implementation of mobile robots always need some support from the machine vision and other IoT sensor expertise that you must have before the deployment. In the end, I would like to show actually one video that is also connected with this use case. So here is like whole like implementation of this or testing of this mobile robot in the factory floor. Their title is okay. It's in Estonian, but yeah. Actually, we try to create the digital twin also of that environment and try to control the robot from remotely through the tablet, but it was just a test. It was successful, but we need to work on further. Okay, so actually that's it from my side. Sorry for little disruption, but yeah, if you have any question, I'm here to answer.
Okay, thank you. Thank you, Kashif. I actually think that thanks to the case study you presented, we have a clear idea of how mobile robots can be implemented in intra-logistics, in production intralogistics. And if the audience have some questions, I remind them they can put them in the chat and we will answer to the questions at the end. Now let's switch to the third and final speech that will be given by Alessio Gugliotta from EIT Manufacturing. He will present the XR to Learn project. So please, Alessio, the floor is yours.
Okay, thank you, Miriam, and good morning, everybody. I will try to give you, first of all, a first overview of the XR to Learn project, which is an Horizon Europe project, innovation action, started last year and will last till mid-2026. And the idea of, so the mission of this project is to create a platform in order to interlink between the different communities that are related to XR technology and apply to education and training. In this slide, you can see the organization involved in this project are universities, companies, and multipliers, including us, that will focus mainly on the training, so on industrial aspects, but there are also educational aspects led by EIT2, and we'll cover a good area of Europe. So where we start, the idea we had of the needs that we have to look is starting from the market, where also Alexander was saying there is a quite active environment in developing new hardware that are more and more powerful, that are not only in the research lab anymore, so they are on the market. There are many ongoing use cases, but also some real applications. And there are different XR development that does not require a lot of large scale investments. But the needs are that most of these experiments or applications are in the gaming, entertainment space, and are dominated by the US market. So the Europe has to make a step forward in this space, especially in the market application. The second area that we have to look to is the education and training. So there is a huge challenge in education young engineers and to reskilling and upskilling current workers. And there is a very rich literature in academia related to the benefits of applying XR technologies in education and training. Tuttavia, however, from the other point of view, there is a need to accelerate this application because there are not a lot of use cases in this space. And there is the idea that the developer of XR technologies should work closely with education and trainer in order to understand the real needs and how to create a more engaging solution. And then another fact is that there is the idea that XR technologies are very costly, but it's not the true anymore. So there is the need to support training organization in order to acquire these new technologies, this new know-how on how to use these technologies. So the idea of XR to Learn was to create a digital solution that is able to interconnect all of these aspects. First of all, we would like to interconnect all the stakeholders in this area. And then you can see from this, on the upper part of the schema, that the stakeholders are different, starting from technology provider, general XR technology provider, but also specialized in education and training environment. There are the company organizations that are creating material for education and training, more related to XR technology, but also in general. Then, of course, there are the consumer of training, so student and working, enthusiasts in general, and in general, there are other stakeholders like policymakers. So there is the need to connect all of this. How to do? The idea is to use this digital platform in order to create a community. Of course, there are already many existing communities around. So the idea is not to create a new community, but to link the existing ones. and then offer them a lot of services, including a catalog of XR solutions. That could be some training material, that could be some libraries to create XR-based applications, that could be tools. And in particular, the idea is that within our project, we'll develop some tools in order to track the IPRs of new XR technologies, or better, new XR-based training materials. We'll create some software, some tools, as you will see later, to accelerate the development of XR-based training materials. We'll make available some demonstration beacon applications, so some applications, some training material that can be used as inspiration to create new and motivate the community to create a new solution. And of course, not only through digital solution, but also through real services, B2B services, to offer support to create. So I have an idea of creating a training material. I don't know how to do it. We can reach us and we can support you to create your application. And then also to create some business, so how to make business out of these solutions. This is a very simple schema of the process that we are going to implement. I will not go too much detail, but the main point that I want to raise is related to that within the project, we will have two approaches. One is called technology push. So within the project, we will create some technologies to simplify the creation of XR-based learning and education materials. And we will see some example later on, some we call enablers, and the platform that will interconnect all the parties. But then we created what you call a technology pool. So the idea is that we will engage with existing players, stakeholders in the market, and involve them by using the open call methodology. So the first enabler that I would like to show you is called Interact. This is a software that will lower the barrier to start to use or start to create XR-based training materials. It is a plugin for Unity plugin for industrial application, so in the virtual reality space. And it is very important, is a no-code tool. So the idea is that, of course, not the learner, not the teacher probably, but some technology provider that has no experience in XR technology can start to use, and without no specific technology knowledge, specific knowledge about the coding, can create a new application. And I will share with you this video of this tool, the Interact tool, where you can see you can use existing RD scans of your set or workshop in this case, and you can step by step create the scene, start to visualize the different elements, and also create a flow. Then, of course, you can go to the virtual reality space and start to review your project, interact with the different elements that you create by using those boxes. And then you can move it, test it, and use it for training. For instance, in this case, training a worker in order to how to put the wheels on the machine. And then, of course, there are many tools and many elements that you can use in this tool. You can see the guy that is working in the virtual environment, making the things. There are also some specific elements that are very important to showcase, like the use of elastics elements and simulate different type of interactions. I'm sorry, the video is quite fast, but I think you can get it, the novelty of some of these features. Okay, let's go to that. The second enabler is called Magic's Room. Compared to the previous one, is more a research activity. The previous ones came from an industrial partner that is called LLV Group, it's a French company. In this case, the second enabler is created by SUPSI, that is a university in Switzerland. And then they are creating a system that is able to collect information from the guy that is interacting in the virtual environment, and is collecting a lot of data coming from sensors, including some sensors in order to assess the status of the guy that is making the experience. The idea is that to understand if some type of activities are stressful for the learner, and try to avoid this type of situations. As I said, it's an experimental activity. There is a specific law in order to define a different aspect of this experience. And there are different scenarios where the learner has to make some activities in the virtual reality space. The system is able to collect all the different data. And the system is also, there will be some machine learning application that will detect the status of this guy and the reaction of the guys from the different perspective to specific critical situation. The third element is called the digital platform. That is the platform that I showed you before. This platform, as I said before, there will be a catalog, including technology, libraries, and different applications. There will be a marketplace where you can buy some solutions available, or some learning materials, or some libraries. And you can access to some learning content system. In this case, it's called SkillsMove. That is a system that EIT Manufacturing created, where you can consume the learning experience. All of this is based on a blockchain solution that will track NFT solutions. And then there is some tool for the community. It's a forum that has been just launched, or better, will be launched in a week, actually, where the different community can interact, discuss about the existing solution or new solution. And there is a wiki for technical arguments. I will be quite fast on this. This is one of the use cases that we are developing in the project. It is a CNC machine, and the idea is to instruct a new worker, basically a new worker in the system, how to use this machine, but most importantly, how to clean the machine after the use. So you can see how at the moment that the machine is being used. And then the system is instructing these guys in order how to interact with the machine, and at the end how to use how to clean the machine after the use. Okay, you can see now what they have to do in order to clean the machine after their use. Of course, there are other examples that has been created in the project. You can go to this YouTube channel of our project and see all the videos. Okay, let me go to the next slide. The second aspect that I was saying before is the pool aspect. So the idea is that in order to populate our platform, we would like to involve third parties. Some of them can be involved by engaging with the community. Some of them can also present their project in order to be linked to our platform. We already made one open call that has been closed in last year, basically, and then been selected 7 projects that we are going to start now. And you can see that the type of application are quite different, starting from the energy sector, space, machines again, but also environment and AI chat training and so on, or paper sector. The important aspect is that there will be a second call starting in autumn and closing by the end of the year, where we also have additional funding available for piloting application. Just to conclude, this is the main features of the project. The idea is that by the end of the project, we will have created a community made by different interlinked communities with more than 2,000 contacts. There are more than 4 million budget available for third parties to be engaged with our platform. We will need to have more than 20 complete education applications available on our platform, business model related to this application, and new enablers that some of them you have seen today, new beacon application, and more than 150 content, educational content available for the use on our platform. Okay. That's all from my side.
Thank you, Alessio, for the interesting presentation. And let's see what results the project will get at the end in 2026. I remind you that the recording of this webinar will be available on SURE5.0 website this afternoon or at least tomorrow. If there are no questions, I think we can close here the webinar, since we are quite on time, not perfectly on time, but quite on time. And if someone will have some questions in these days, obviously you can write to the contacts on SURE5.0 website, and we will put you in contact with the speakers directly. So thank you very much for your time and for the contribution of our speakers, and see you at the next webinar of SURE 5.0 project. Bye. Have a nice day.
Thank you. Bye.
Goodbye.
Bye.
Bye.